My name is Jordan Garcia. I think the original title of the presentation was something about nuclear JS. That is a Flux implementation that uses the immutable JS library. I will not be talking about that tonight. Instead, I will be talking about how to take some of the ideas that Logan presented on with immutability, with one-way data flow, with pure functions, and how do you implement that in the front end in JavaScript? Maybe you don't have closure script like everyone at Prismatic. Maybe you're working with a more mundane toolkit. But I'm here to show you that you can implement a lot of these same ideas and concepts with JavaScript. So a little bit about me. I'm a software engineer at Optimizely. We're the world's largest A/B testing platform. Pretty recently, I refactored Optimizely's front end to be Flux based with Vue.js components. And if you're not familiar with Vue.js, it's a lot like Angular's directive layer, but without controllers and factories and providers and services and ng route and everything else. And I love functional programming. I think Clojure is like the coolest language ever. I'm very much interested in modeling stateless systems and data flow modeling. So what is a stateless UI? I don't think there's a very good definition for this because, I think we kind of just made up the term. But in my mind, it's a few things. One is UI components or visual elements don't manage their own state. So they can have state, like in Angular, you have a scope, but the owner of that data is not the controller. So that means some other part of the system owns the data. So you have a completely separate system that manages the state and the data flow of your application, and your visual components simply mirror that state. And what I also would consider a condition for this is that the application can be put into any state or reset completely at any time. So why do we want this? Like, UIs have been written statefully for a very long time, and you can do some cool stuff. But in my mind, the more state you move out of your visual components, out of your view layer, the thinner your UI becomes. And that's very beneficial because it means that your UI is such a thin layer that refactoring it, that swapping out the UI components, swapping out the workflow, the actual user experience is very easy because you have this abstracted notion of your data system that's decoupled from your UI. It provides you a data abstraction that can be reused. Once you model data, not in a UI, and actually model just an interaction, then you can use that interaction wherever you want, whether that's on your desktop site or your mobile site or a different site completely. You've encapsulated an abstraction and you can reuse it. That's very important. And the other thing is testability. Like being able to put your app into any state and to introspect on that state without the cruft of carrying a full UI layer with you is very powerful. So I'm going to talk about Optimizely because we just went through a very large refactor of our front end. We refactored it from originally a year ago. We had Knockout.js. It's a good library, but our app, we support IE10 and above, so we can use cooler stuff than Knockout.js. And Knockout.js's main problem was it had no reusability. So when you wrote something, you wrote it for a specific page, for a specific implementation. And if you wanted to reuse that code somewhere else, we literally copy-pasted it. Like half of our code base was just copy-pasted code from other view models in Knockout. So it's not a very sustainable or scalable way to go forward. So after some deliberation and figuring out that everyone at Optimizely hates AngularJS, because who doesn't love to bash on Angular, right? So we picked Vue.js, which is like Angular's weird little cousin. Imagine Angular without anything but directives. So it's actually a pretty nice model. The library isn't as mature as Angular, but it's very single-purposed in what it does. So I think it definitely has feature parity with something like Knockout, but it provides very nice portable components that can be reused across our UI. So that's cool. Like everyone wants UI components. I think that's like what the front end community has been going towards is how can we make our UI reusable? Like everyone wants that. And then after a few months of unleashing Vue.js on about 20 developers, we now have a folder of like 100 components. And it's very hard to manage, one, the code complexity, but more importantly, how do we share data between our components? How do we share state between our components? An example of this is, imagine you're just on a page and you have a component that has a list of things. You have another component that edits something in that list. Like, how do those components talk to each other? How does one component that edits something tell the other component that that thing has just been edited? And that was probably the most contrived example possible. Like, imagine this like over the network or across pages. Like, you want a UI that stays in sync, and you need a canonical data model to do that. So that's where the idea of we need a data model that's decoupled from our UI came from, and then we move forward with that goal in mind. So the problem was, the more portable and reusable our UI components became, which is a goal from the beginning, the harder it became to actually keep them in sync and share data. And I think that's an inherent problem with component UIs, is you have portable things that, because they're portable, they have stricter boundaries. So you can't just share state between them. So we came up with a few solutions. A couple of them worked okay. The first solution was that we had like a parent or root component, and I think we actually called them controllers at one point, that weren't necessarily UI specific. They were essentially the managers of data, and the child components could talk to the parent to get the data. And the nice thing about this was, hey, we were keeping stuff in sync, right? I mean, your UI would suck if you didn't do that. The cons, which there were a lot, it's very tedious to pass data up and down a component hierarchy, and it's kind of gross to say that we were passing it up and down, which we were. The other problem was that state had to now live on the common ancestor. So if you had a component that needed some state, and it had like a sibling component that needed the same state, like then you just put it on the parent. But what if you have a component on the other side of the DOM hierarchy that also needs that state? Well, in this model, you now have to refactor that state to the common ancestor, which is probably something at the very top of your component hierarchy. And the state could be very specific, something that doesn't belong at the root level. So it forced us to model our data in a way that wasn't ideal at all. We were compromising our data modeling based on the constraints of our own system, which, who wants that? And then we're still putting application state in UI components. Like, that's the root of the problem, is like there shouldn't be application state in a UI component. So that solution sucked. We had another solution for this, and this was actually even worse. So we thought it'd be a good idea to use events to just, Vue has a nice event emitter like Angular's scope.emit. So it's like, we'll just shoot events between all of our components. It'll be awesome. It wasn't at all. I mean, the only thing that was nice about this is it wasn't the previous solution. It was really hard to understand. Like, and part of our code base is still like this, and you can't understand it. It's like, this component emits this event. Who listens to it? And sometimes, like, you would namespace your event. So you'd namespace it with a variable. Like, how do you grep for that? You can't. It's impossible. And it's anytime a component changed state, it was the one responsible for telling the world that it changed state. So you were inherently coupling your components together, even with this decoupled solution. So it was bad. So our solution actually was Flux. I've been a fan of React for probably about the week after I chose to use Vue.js as our front-end framework of choice. And I saw Pete Hunt talk, and he talked about Flux, and I was like, this seems pretty cool, I'll check it out. And it made a lot of sense to me. The data and the state were completely decoupled from the UI. Components can subscribe to any state. There isn't this notion of an artificial hierarchy that so happens to correlate with your UI components. It's state over here, UI over here. You can do whatever you want. Like, they can talk to anything. It doesn't matter. So components were very easy to keep in sync. Like, way easier than any of the other solutions because they were just syncing with some other system that was managing all the data of the application. And it provided a very easy, predictable data flow. Logan talked about this a lot, where it's a one-way data flow with like an event tick to it is very easy to reason about because you know that there's only one way to change the state of my system. And once that state change happens, it can never cascade to other state changes. I think that's the problem in so many UI frameworks right now is it's all pub sub or it's all like, a digest and then it loops and loops and loops until it settles. Like you can't predict that. I don't think there's anyone that can take, a full-blown Angular app and say when this one property changes, I can predict how the entire application changes from that because it's not possible. But you can with Flux. And some of the cons to it, like it's a lot of boilerplate, but we're an organization that has probably 25 engineers that operate on the UI code base. I'd much rather have something that's simpler, easier to reason about, that can scale out horizontally than something that you can write the sexiest to do MVC in. And it is a new design pattern. And whoever asked about the kind of Flux versus MVC, I do think Flux is MVC. It's just not your traditional object soup MVC. So show of hands, who all's familiar with Flux already and who doesn't know about it? Okay, that's like 40%. So this is a Flux system. And this is not Facebook Flux. It's kind of a Flux we implemented ourselves. There's kind of one difference here between Facebook Flux and our Flux, and I'll get into that in a second. But the idea is simple. You have a dispatcher that basically, it takes in a message, and it sends that message to every store in the system. And you can think of a store as just a piece of state that reacts. So it's not state that you can change, but it's state that you can say, hey, I'm going to give you a message. And if you want to update yourself and change, like you can, and then you'll let me know. So that's how it works, is you dispatch an action into the system. That action goes to every store on the system. So an example of a store for us is like we have an account store that holds the user's account information. So when we load the page, we dispatch a message that says account info loaded, and the store updates, the account store updates. So all messages go to all stores. Stores are the only ones that know how to update themselves for those messages. So that means the store is in charge of managing its own state. So you don't have a system where other parts of your system are reaching their hand in, imperatively manipulating some state in your system, and you're cool with that. It's this store manages a certain domain of your system, and all you can do is send messages into that. So that's a constraint on the system that works very well. And then these like triangle things, we call them getters, and this is where we kind of deviate from Facebook Flux. Facebook Flux has the idea of dispatcher.waitFor, and in my mind, that's not ideal. It basically is saying that your stores know about other stores. Does that help? It says that your stores know about other stores, and this store has to react to this action before this other store. So I thought, why do we need that? Why can't the stores be siloed completely? They don't know about anything else in the world. All they know about is, hey, there's a dispatcher sending me messages. If I care about any of those messages, I can update myself, and then I let the world know that I've updated. So that's cool and all. It means your stores are very siloed. They're very portable. They can be swapped out. They don't rely on other stores, but that means your data is siloed. So you have no way of forming relationships between your data or actually figuring out, a bigger picture. So we use getters. And getters are a pretty simple concept. They're functional transformations that take state from one or more stores and combine and transform that state into some value. And I'll get into that more into the presentation. And the other part of this diagram is actions can come from anywhere. They're messages. They're JSON serializable. So they can come from a WebSocket, they can come from a UI component, they could come from an iframe, which we do. Like, it doesn't matter. They're messages. They get sent to the system. As someone on the other side of the system, you don't care about it. All you care about is observing the stores. And then if you're sending messages, you don't care about what happens with that message. You just send messages into the system. So this is an example of a store. I'm sure half of you can't read this, but I wanted to throw in some code. All right, stores do a few things. When they initialize, they set their own state. They set their initial state. And then they also say, what events, what messages do I listen to? So this is an example of a store we use on our dashboard. So I'll go ahead and show you. So this is Optimizely's new dashboard. It's still in beta. It comes out, I think, tomorrow. So we have a few cool features. One is we have a sortable and filterable table. I mean, I don't think anyone's ever done this before on the internet. You can like type stuff in here, so I can type like, I don't know, fuzz. And it sends me back only the result that matches fuzz. Yeah, that's nuts, right? And this goes back to my example before where, hey, you have a component like that's not the same component, and you change it. So I'll change it to like fuzzy. They both updated. Now, it's very impressive what's going on. But it's actually, these components aren't talking to each other. If we go back to our diagram, what's actually happening is when you key up on that input box, it's going full circle. It's saying dispatch a message into the system that says the filter changed, the string filter for the experiments changed. And then we have a store that tracks that filter value. And we also have a store that tracks all your experiments. And we use a getter to functionally compose those two stores together to return to you the experiments that match that filter value that are in your memory. So what that means is that if any action changes the value of either of those stores, then this getter gets rerun. So the UI gets re-rendered. So if an experiment was added via a WebSocket, to a server that says like, hey, someone else on another account added an experiment, that's treated the same way in our system as adding an experiment yourself. All we're doing is we're saying, here's your filter, here's your list of experiments. Anytime they change, we're going to recompute this function that gets you your filtered experiments. And there'll be more code to back this example up in the presentation. So back to our store example, stores subscribe to messages and they have methods on them. That's it. And the methods are for reading only. So in this example, we have this dashboard set table filters action. So that's like the type of the action or the message. And then we say, when you see this message, call this set filters function. And in the set filters function, it takes a payload, it pulls out what category it is and what the filters are. And the category is used so that we don't have one filter per instance, or I'm sorry, one store per instance of filtered value. So this store manages multiple values. And then we say, if the new filters aren't equal to the current filters, change yourself and then tell the world you've changed. And there's only one change event. So granularity comes down to the store level. If you need more granularity, you can build more stores, or you can actually add an argument to emit change and say, as a subscriber of this, I only care about this argument. And in Nuclear.js, which is the Flux implementation that Optimizely open sourced, there are mutable values. So you can actually just subscribe to any store at any granularity, And there's no emit change. Because they're immutable values, deep map lookups, so map comparisons, are essentially free. It's a log32 operation because they're immutable. So this is what an action looks like. We use Flux as a singleton, and we dispatch something. So this is a dispatched action that the store I showed you earlier would listen to. So the example is we would have a category and a filter, and the string would be the filter string. Come on. All right, so now to getters. I talked a little bit about them earlier. They're functional transformations and composition of data in one or many stores. So if you need data from more than one store, use a getter. And this obviates the need for dispatcher wait for. And this is an example of a very commonly used store. So getters are actually just arrays. They take string values or other getters, and then the last value is a function. So if you're familiar with Angular, it looks a lot like their dependency injection that isn't like the magic read the function argument one. It's just an array, strings, function. So in this one, we have a current project store, and we have an experiment store. So this getter is getting us all the experiments that match our current project. And in Optimizely's product, current project is it's essentially UI state, or it's the state of your current session. So getting the current experiments for your current state is a very useful operation. And all the getter is doing is it's saying get the ID. If you find an ID, try to get all the experiments in the experiment store that match that ID. That's really nice for getting experiments for reading stores. It provides a nice modular abstraction for the notion of pulling some data out of your system. But I think the really nice part about getters is that you can compose getters with other getters. So instead of just strings, you can actually put a getter in here and use the value in the function. Yes? What is that get ID? So the current project store maintains one value. It maintains the current project ID. So that's UI state. So when you log on to Optimizely, you're put into like a certain project. And you can change projects. You can have multiple projects in Optimizely. So when you change projects, then this store will change your current project ID. So if you have any UI component that subscribes to the current project experiments, this will update. And this is an example of composing a getter. So we're using the current project experiments along with our table filter store, which you saw earlier, to get the filters from the table filter store. And then we're saying if we are filtering by a string, actually filter our experiments. Otherwise, just return our experiments. So this idea of getter composition allows us to define a canonical way to access a certain part of our data. And if we need to do any transformation on that later, we're just composing the canonical form. And what happens is a lot of business logic ends up in these getters. And it's actually a really nice thing because a getter is essentially an immutable value of strings and a function. They're very easy to test. They're essentially portable because they're arrays. You can send them over the wire. You can do whatever you want. And all the functions are pure, too. All right, so I want to end on an example. So I really like to live code in presentations, so why not now? So let's implement this. We have everything we need in place. We have the store that holds the filter value. We have the Flux system. We have an action that will say, I'm filtering by this value. So let's hook this input box up to actually filter the values of our experiments. Yeah, this guy right here. I choose you, sir. All right, And now I just have to get out of this thing. That's step one. Okay, so let me find my presentation. Where am I? Thank you, thank you. Oh, there's a good Vim joke, but I won't tell it. All right, so this is where I am. So I want to hook this up. I want to make it so when you type into this search box, it will dispatch an action. So for this presentation, I put like a version of Flux in the slide deck. That's why I used Reveal.js. So I'll just type a script, do type text JavaScript. Then here I'll say var input equals document get element by ID search. Then I'll say input.add event listener key up function e. Did I do something wrong here? No. And then I will do Flux. So I've exposed Flux through just a global variable, and I'll say dispatch. Actually, let's just copy the code from the other slide. I think that would be way easier.